Okay, I gave myself about 4 minutes to do a video on in behavior of polynomials, and I wrote down all these rules, and frankly, I'm hoping that at some point you'll stop the video and that you'll write these rules down, and it's it's really what I'm not going to go through too much, but let's talk really quickly about what in behavior is saying. We start with this polynomial, and it's a sub n x to the nth plus this mess. All it's saying is this is the coefficient. This is the coefficient of the first term, and we're saying the first term is the term that has the variable with the highest exponential value, and then this is the second so the second term is the variable with the second highest exponential value, etc., all the way down. And that's all that's saying. And then this f of x idea just says what height. So f of x is just height. What height? So it says here what the height as x, the height approaches infinity. The height gets super tall as x approaches negative infinity. Here's negative infinity here. Negative infinity. So what's negative infinity? So what this says here is as far left, as I look to the far left, what does the height do? So all this says is this. It says if the coefficient of the first term is positive and the exponent of the variable is even, then we have this behavior that f of x approaches positive infinity as x approaches negative infinity. Okay, just stay with me for a second on this. And all of these situations describe what can happen. Either the exponent will be positive or negative. Either the exponent will be even or odd, and either the lead coefficient will be a positive or negative number, right? So here are all the possibilities. So I'm going to encourage you to go back and copy these rules down, but instead of going through all the rules with you, let's take a look at a couple and see if the rules don't just follow pretty easily. So here are some examples. So here's example 1. Example 1. So example 1 is, what is the in behavior of f of x equals negative 5x to the 4th power? Well, what I did was I went to my calculator, to be honest with you, and I was like, you know what does this look like? So I graphed this on my calculator, and the calculator comes back and it gives me a picture that looks like kind of like this, something like this. It's doing this. Okay, so let's see what we have here. We have a negative coefficient and an even exponent. So negative coefficient, so that's less than 0, and even, right? So that's this situation right here, isn't it? Negative 5, so this is less than 0, right? Negative 5 is less than 0. And then the exponential value is even, so that's this situation here, isn't it? And it says here that f of x approaches negative infinity. The height, look, right? The height. It says here as we go to the negative infinity, so as we move left, right, the height goes down, doesn't it? We're only talking about end behavior here, end behavior. So I don't care what's happening in the inside. It might switch directions or whatever it might do, but as we go far left or far right, what will happen? So then the second part of that, right, we're here, says as x goes to positive infinity. So x positive infinity, this is x is 1, 2, 3, 4, 5, a million, 2 million. So as we go this way, which way does our function go? And as we go this way, if we move over here and we look for our function, which direction is it heading? Well, it's heading down, isn't it? All right, let's look at another example. So this is very, very predictable. If you memorize these rules and look at some examples, this gets really, really easy. So let's look at another one. So example 2, if you don't mind. Example 2. Example 2. And for example 2, let's let f of x equal negative 6x cubed plus 10x. And what I'm trying to convince you of is this. What we're going to be looking at is this. When we look at this and your professor says or your teacher says to you, what's the in behavior? Make sure that the terms are in order, right? In order. That's the highest exponential value of a variable first on down. We're just going to look at this first term, and we see two things here. One, the coefficient is what? Right? Coefficient is negative, so that's less than 0, and the exponent is 3, so that's odd. That gives us this rule up here, doesn't it? So we look, and it suggests to us that what's going to happen here. Suggests to us that this is what's going to happen, that as x goes to negative infinity, this thing is going to become positive, and as x goes to positive infinity, as we move to the right, this thing is going to become negative. So I have this rule memorized, and then I went and looked at the graph, and I was like, is this thing going to hold up? And what the graph of this looks like, frankly, is this. It looked like this. Let's some interesting color. It looks like this. It comes down like this and goes back up and heads back down. But just to be clear with you, what we really care about is what happens as we go that direction. So if we kept following the graph, what would happen is this thing would just keep going up towards. So as we're moving over, this thing gets incredibly high, doesn't it? Which is what we expected. And as we keep moving, as we move in this direction, as x approaches positive infinity, well, then we have this thing. It's going to just keep going down, isn't it? So these are the bits right here that we're really looking at. The inside parts are inconsequential, aren't they? Look, as a matter of fact, look, it goes down, it starts heading down, it looks like it's going to go really deep, and then it comes back up, and it's increasing, and then it's decreasing. But at the very end's what's happening. So there's that answer. Let's look at just one more example. If you don't mind, I hope you're hanging in there with me, because I think if you work on this, memorize these rules, and then look at this over and over, you'll see the rules will really, really help. So here's the next one. So we have 3x to the 8th power, right? Minus 4x cubed. And so I looked at this function here, and this one is kind of a weird looking function, and it has this weird shape here. And the shape that this function has is this. It goes kind of down like this and dog legs back up, and then goes down again and then heads back up. But remind yourself, what part do we care about? We care about the part way over here, right? And we care about the part way over here. So let me ask you the question. As we move in our graph, as we move as far left as possible, what's the graph doing? Increasing or decreasing? Is it getting super tall, or is it falling towards infinity? So we start answering the question, and we say, okay, well, I looked at this first, and I said to myself, as x approaches, I don't know, negative infinity, right? So that means we're going this way, right? And as we go this way, what's the graph doing? What's the height? Remember, height is f of x. What is f of x doing? F of x is increasing, so it's moving towards positive infinity. Just means it's getting very, very tall, isn't it? And in exactly the same way, if we look at it the other way around, we say, okay, well, what happens as x approaches positive infinity? Well, the height approaches what? Well, positive infinity, x would be over here, isn't it? And sorry, remember that, sorry, because I got my two graphs touching. So let's pretend they're different. Let's realize that they're different. So we'll disconnect those. So as we move this direction, positive infinity, x, what's happening to the height? Well, it's soaring, isn't it? It's increasing very quickly. So we can say with some confidence that as x goes to infinity, f of x also goes to positive infinity. Okay? I hope this is helpful. Again, I'm hoping, one, that you're still with me, and secondly, that at some point you write these rules, and it looks like a lot of crap here. I realize that it does, but if you take a look at this, it will become really easy, and with just a little bit of work, you'll start to see these things really quickly, and you'll see an equation, you'll say, oh, this thing does that. So good luck, and keep working.